Hello, hello. Got some new mic settings here, so hopefully it sounds okay. I guess if it doesn't, people actually start joining, I will ask again later. Okay. Got a bunch of to-dos today that I would like to start tackling, but I think first I want a new keyword, a new directive for concatenation. So let's go add that to forcoder first. Here, add a new one, and I think this is another one that is built in that I'm going to have to turn off. Or at least rename off of the default forcoder ones. Preprocessor ops. Okay, I think we're good there. That should be fine. Let's do that over here. Custom. Do I have a do whole thing? Okay, that should have closed forcoder, which it did. Now we should have a new keyword. We should be able to say concat. Boom. Okay. So, let's go to the Lexer and add a new directive called concat. I feel like I need to rethink this because some of these I don't know. Like some of these are token preproc, most of them are, but then these initial ones I added new token types for. So whatever. That's fine. So we are now lexing them. We should now not understand what this thing is. If I say like, let's do short string value. Let's say, let's just concat value, I guess, or argument. Which we'll just see what this does. Let's just start with this. Let's also just have it stringify it. And then we'll just pass that in. Oh, well, I guess we just do this as well here. Yeah? Maybe we need a better name for this than concat, because... Well, we'll think about that later. Let's just get it working first. So, should not understand what this is. What happened to my... Did I seriously close that? I did. Oops. Okay. Let's run this. The fact that it's frozen is not good. Is preproc expression. So this doesn't understand this. But but it shouldn't be freezing us. So if I turn this on, does it suddenly stop freezing? No. So before we do that, I want to add proper error checking here because starts expression. Oh, okay, this is dumb. This should be token type is pre-proc expression text. Is pre-proc expression text. Okay, there's that. Let's go to parse expression leaf and pre-proc. Here we go. So we should be hitting this, and we're not. So that's a problem. So where are, I guess we're already opening VS Code. I want to see where we're halting, or where we're like stalling out. Okay. Parser. Let's just start the program. And pause. Where are we? We're in scene this type. Where are we in the token cursor? 134? Okay, let's stop here and say parser token cursor is 134. I want to see exactly what we're doing here. Okay. The next thing is probe. Where do we have probe? String builder. Okay. Wait, something is messed up here. We are not even close to being in the right place. What is happening? There we go. We were in a really weird place. All right, expression. It's assignment statement on line 37, and we're in the string builder. Next is, okay, I don't think that was the right place. C string. Okay, that's why. So let's go over this. We're in C string. Okay. Next is a semicolon. Advanced, peak, boom, 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 boom. Next is variable C string on line 28. So where are we? What is happening? Let's go to C string. Line, what did I say? 28. We're right here. We're in a snippet. This seems okay so far. I don't see... Are we really getting stuck here? I'm just going to keep going until we get stuck. Because I don't think it's here. Let's remove this. Let's set a breakpoint on do parse. Right here. $134. If we keep going, pause. Okay, I'm not entirely sure why we're still looping forever. I'd really like to know where this is happening. Because if I don't have these things here... I mean, I'm not even calling this snippet either. Yeah, so... we are just failing right there. Spectacularly. So, let's do this. In the parser, in do parse, let's just print out the token. Every single time. Value, and just see where we end up. Short string. Okay, that's got to be it. Oh my god. I gotta stop doing that. That's gotta be on line 140. Yeah. Plus line. How do I get to string int to string? I already forget how I get my strings and stuff. So value. No. Next line number. Nope. Line. Nope. I need a plus. Yep, line 140. Okay, we're definitely breaking on concat, but why are we just not handling it? Let's go back down to do parse. Do parse. And let's just break here when we are at 140. Where are we? We're not in print, not in dynamic string, we're in main. Okay, we're in the snippet right here. Although, shouldn't we have gotten the name? What's the next thing? Short string. I don't know why we didn't see the name here. Oh, because we're only printing out this token. When we saw snippet, we ate the name there. Okay. So, it does start an expression. Our lines are off. I really don't know why that keeps happening. Why is that happening? Oh, it's because I did make a change. That's why. Print dynamic string main. Okay. So, should not be a known type. It is, though. Okay, why? We're saying it's a function or a variable decal. Oh, because next is, this is not the concat, this is short string. Okay. Let's parse the function or variable decal. Oh, right. Concat can show up in a name. We're expecting this to just be an identifier. Concat is for identifiers, right? This is to let you append onto an identifier, and we currently do not. Where do we grab the identifier here? Keyword, tilde. Don't skip. Type is type here. Type is short string. Parse multi-node result. Where is var decals? So we didn't get anything, right? When we go back through, yeah, we just didn't do anything with that. So we're just stuck in this loop. So inside here, we need to handle when we see concat. After next is this preproc, right? We're seeing if it's a parent open, if it's a keyword, if it's a tilde. It's none of these, so we just bail. So I feel like let's narrow down where in this stack we actually handle identifiers. So where are we? 2, 3, 9, 4. We can recognize a few cases early. So after next, this is going to be our identifier technically. If it's a parent open, we look for a function pointer. Otherwise, if we're in a struct, it could be a constructor. Otherwise, oh, this is if the next thing is a parent open, which it's not. So if it's a keyword, if it's a tilde, otherwise, skip all this. It's either a regular function or a variable decal. So we grab the type, and then next here's where this is. So it's either going to be an identifier, a preproc identifier, or a token preproc whose we're going to say is concat directive next. So is this concat directive? It's going to take a token, return token type is token preproc, and the token's text equals concat, right? So if this is a concat directive, we also want to do this. So do we store the identifier here? We don't. So here's where we try to see if this is a function decal or a variable decal. Parse function decal or parse variable decal. So in those two functions are where we need to handle. Let's do variable decal first, since that's what we're doing right now. So in here we should be grabbing the identifier somewhere. right? Here's where we expect there to be a name. So here when we're saying expect token, we should be hitting this now. If I build this, which we are, great. Expected identifier, we got a token pre-proc concat. Although expected identifier after this got this. This is a bad error. This should be next is all this, is all this. So even before this, although hold on, why are we skipping anything here? Oh, this is just type. This is after the type. I'm so confused. Is this really the... Is this the thing we're hitting? No, I'm actually confused. We're not expecting this one. Token identifier. Oh, that's the curly... Oop, hold on. Where are we? We're down here. Maybe this did work and I just had it in the wrong place. No. So if the next is a comma or a parent open, we just return that. Otherwise, we expect a curly open if it's an any of. If it's an ellipse, we skip it. If it's a parent open, okay, this should be type, I think. But I put it in the wrong spot before. Yes. Expected identifier after the short string, we got concat instead. That's what I wanted to do. So we are now properly identifying this situation. When we go to get this identifier, it doesn't know what concat is. So this needs to be more robust. We need to say expect identifier. So let's do that. And this will be a little smarter than just looking for a token identifier. It's going to know about concat as well. So it's going to take the token, current, and it's going to take the context. Okay, so let's just do what we're doing here. But if not, do we have a starts identifier? No. Parsing C broke your soul, but I'm finished now. Nice. What have you been doing? Curious. I started by parsing C here, but at this point it's kind of ballooned into my own thing. Bind gen tool for your language. Cool. That sounds awesome. That's kind of where we're at here on mine. So my little like language over here has got stuff that C doesn't have. So like right now, I'm implementing concatenation for like these snippets are basically macros, only they are parsed like regular code and like an AST is created and the AST is inserted into the fully parsed AST is inserted into wherever you call the snippet. And I need some extra functionality that you get from macros, like concatenation, so that's what I'm doing right now. So we are expanding what it means to be an identifier, because now you might be concatenating stuff to your identifier. So if next, if it's not an identifier, and it's not, I forget what we use preproc identifiers for. Yeah, I guess it's just because we technically still parse them. I don't even know if we do anymore, though. But I might as well keep it here. Because we do it in other places, but that could do for some cleanup, honestly. And then, if it's not an identifier, or a preproc identifier, or not is concat directive. If it's none of those things, we expected an identifier. Got that, return true. So, this should now explode, because we are now passing right on through this. Although, oh, that's a parse error, great. This is going to go bad, because now we're going to pass on right through that, and right, I called this error you know what? This is just the context. Okay. Okay. I was not expecting to compile. That is strange. What did we insert? What did we do? How did we compile? Stringify. Oh, it won't show up there. It'll show up in the tree. How did we compile? I'm very confused by this. Stringify. So we have a variable who's called concat, whose type is short string, and it equals argument stringify argument. Okay, yeah, so it's getting confused here. There's an extra decal ref. So let's do this. If I do this, stringify. So this is what I would expect, right? It's a decal variable called arg. Its type is short string. It equals. Oh, because this is a decal variable. There shouldn't be an assignment operator here at all. It inserted an assignment operator before. Right. So this is just a decal variable whose value is a preproc expression stringify that I passed argument to. Whereas this added, it interpreted this as it inserted a assignment operator in there for some reason. So see, now we're saying it's a decal variable whose value is an assignment operator. We're assigning, right, it's ignoring this, these parens. So it's thinking this variable is called concat, and its value is this expression argument equals stringify argument. That's really weird. It is totally confused about this, which is fine because we're not done doing this yet. So we expect an identifier here. Because see, then we're just saying, hey, get the text of the thing. But that's not going to work for us. We want, I guess, a dynamic string. Let me see what variables use, because I actually don't remember. They're just short strings, it's fine. Short string name equals parse ident. We're going to have a parse identifier function here. And it's going to take the parser, it's going to take the context, and I think that's it. And you know what? We can, if we're calling parse identifier, we expect there to be an identifier. So we can call that from within there. We can put that up here. Parse identifier, and we can expect one, which means we need the current thing, which I guess we do need that. So I don't love that. So actually let's leave this here. What did I just do? Let's leave this here. I don't want to have to pass in the current token. There's no reason to do that. So parser and the context. Then we are going to parse an identifier. So we're going to say, oh, this doesn't return a node. This returns a short string. So I'm going to show you short string result. And here we go. So we're going to keep going as long as we hit either an identifier token or a concat node, or a concat directive. So let's grab next. We're going to say while next and next type. Let's add a utility function for this. Let's add a is identifier token. So we're going to say token type is either an identifier, or it's a preproc identifier, or it's a concat directive. Might as well do this. I don't really have to do this, but okay. Wait, is literal type? Why do I already have an is literal? Oh, because that's for tokens. That's a bad name, but it's okay. Let's not get distracted. So, is identifier token. That's great. So, well, next, and next is a identifier token. We are going to say, ooh, actually, this is a little weird. Maybe it's not. We'll see if this works. I'm not sure if this will keep. So, like, if we say this, say we did this, right? So this should come out to a variable called hello underscore whatever you passed it underscore world. I think the lexer and the parser is smart enough to count this part as an identifier. Actually, we can just see, right? Let's just see. Let's just see what it spits out. Oh no, that won't tell me. We'll just see. We'll just see what we get. Let's just dive head first and see. Dive in head first and just see what happens. So, as long as we have that, if let's do a switch on what we have. Okay. We have three things this could be. An identifier. And actually, this case is identical. What am I doing? Those two things are fine. This requires more work. In this case, we do exactly what we did over here. We say result plus equals this. In this case, though, let's break here and see what we get, because I'm actually, I don't know if I can think through this right now. Because I don't actually know what we're seeing here. I think we're seeing the parens and all that stuff. That's an infinite loop right now because we're going to advance. Okay. Great. So let's go in here. Let's go to parse identifier. Stop this now. Let's go here. Start here. So, result after this should be message. Wait, where are we? Where? Oh, because this is happening. Okay. We're now going through this for every variable that we do. We want this. Okay, we are failing though, like immediately. So let's just see what happens. Advance, next. Okay, return result. Oops. Would help to use the thing that we said. And in fact, why don't we just do this? We already know an identifier's next, so let's just do that. Still didn't work. Well, let's figure out why. So this var decal nodes name is message. We advance. We Oh, we're probably skipping one too many things because parse identifier. If we see the next thing is an identifier token, so we're seeing message. We skip past message and peek the next thing. Then we leave to here. And we skip the next thing. So, we don't have to do this anymore, I believe. Yes, okay, great. We compile now? We compile now. That's weird. Let's see what's happening. That part's fine. Let's jump down here now. Okay. So result right now should be hello underscore. That's what we should expect result to be, which it is, right? 1, 2, 3, 4, 5, 6. It's a string of 6. It's hello underscore. Okay. So we are seeing the preproc. Let's skip past it. Wait, what was next? Yes. Okay, great. So we are seeing everything. We're parsing this whole thing. So, let's do this. Parse identifier. Let's have a helper for well, you know what? Let's see what's in it. Hold on. Let's see what's actually in this thing. We're at hello. Right. We need to skip past the... Skip the open parent. It should be an identifier in there. So we can say next, it's peak token, parser. And you know what? Let's expect an open pair in here. This is not next. We need the previous thing. This is kind of an annoying part of this. So next is the next thing. Okay, let's expect before the type. We're expecting a token parent open. And the context we're passing in. Skip the open parent. Now we can grab the identifier inside. We can just grab this. And we expect this. I think. Yeah? And actually, let's say parent is peak token. So let's grab the token here and say we expect identifier, parser, parent, context. Okay, so we expect an open parent after the concat node. If we have one, we grab it and skip it. Then we say, okay, now we expect an identifier after our parent. We grab it. And actually, we don't even have to grab it. We can just say result plus equals get token text. Next. We have to actually get it. Yes, we have to actually get it. And actually we already know it's an identifier, so let's grab it. And then we expect that, skip it. Okay. That's messy. I think this is it. I think this is all we have to do. Expected parent open after hello got concat. Okay, we shouldn't be getting into here at all if we hit. So, okay, we're here. It's an identifier. Result plus equals that. So we get hello underscore. We advance to concat. Before equals hello underscore. Next equals concat. Boom. Now we see this. We expect after next an open paren. This is next. Because next is our pre-proc. I don't actually think we need this. This was premature. So after the concat, we expect an open paren. We grab it. Right, okay. We need this. We need this to be... I was getting ahead of myself here, so... We are on, right now, we're on the concat node. So we have to skip past it. Grab the next thing. No. Skip past it. Expect the next thing to be the parent open. We don't have it before anymore. This is next. Okay, we compile. That's a good sign. So, let's go here again. Okay. So, let's close all this stuff. Next is concat. Result right now is hello underscore. Okay. And the next thing is concat. Skip past the concat. We expect a parent open. We got it. Skip past it. We expect an identifier now. We got it. So here's next. Here's the identifier. And the identifier is called argument. So the result plus equals argument. Boom. Oh, wait. But we don't want... Sorry. This is actually not how this should be happening. This is all incorrect. We are actually not... The parser is just supposed to be sticking a concat node on the AST. Right? Because whatever you pass in should be the thing that we replace this with. This part needs to happen later. All we need to do here is say, hey, there is... We need to somehow condense this whole thing into a single identifier node, and then this part can get replaced later. Right. Didn't think through that fully, so... I think we still want this, but So we don't actually have an identifier node here, because normally it's all part of something else. Okay. I feel like this is a little tricky. Yeah, how do we do this? So this on the tree right now is a decal variable whose type is short string, whose name is just a string, and whose value is what's after the equals. The problem is, at parsing time, we have no idea that this connects to this, which connects to something else from the call site. We don't know any of that stuff. That happens later. All we're doing right now is building the tree. And right now, identifier names are just strings. We cannot turn this into just a string in a way that maintains the fact basically anywhere here where we have a name on our decals, anything where we have a name on our decals need upgraded. They need to be upgraded. Which I don't love, because when we're showing them on the tree, man, I actually don't know what I want to do here. We don't actually have a tree to look at right now. So here's the name. That is not really supposed to be a node on the tree. Like, you can imagine I could make a AST decal identifier node that becomes a child here. But then it suddenly doesn't, it suddenly makes this a lot more confusing. Like, here's a decal function. Its first child is actually its name. Like, that doesn't make sense. So, okay, maybe their name is actually just a linked list of nodes, and those nodes don't show up directly on the tree. It's a linked list of nodes that, when I go to print the tree here, I traverse the list of nodes and construct this name. I'm trying to decide if that's gross or not. To hide nodes from the tree, which I already do in some cases. That's probably fine. Let's start doing that. So let's say we have a new node type, and I don't remember which ones are hidden already. Do I have a thing here? Yes. Array dimensions are nodes. Right. Anything that you would put in here are actually nodes on the tree, because they could be decal refs, but they don't show up on the tree that way. So let's do that for now. Let's create a new struct. metagen decal info, or how about decal name? These nodes are hidden from the tree, but are necessary to construct a linked list, but they are necessary to support concat directives. We store a linked list of these hidden nodes that the CodeGen can later construct into a full name. Okay, so we have the name. We have a pointer to another one. I think we can just do that, and then we can just chain them together. So in this case, this one would have 3 of them. It would have one called hello, a next that points to a concat node, and then a next that points to a world. And although these nodes don't currently have so these can just be a simple thing that has a string on it, but this one needs to be a node in and of itself that has children. Or I guess it really doesn't. Okay, it really doesn't. This can just have a because all this can be inside of it is an identifier. So its name its name can either be a string, like in this case it's just hello underscore, or its name can be a node, which is this preproc concat that has this as a child. Let's do this. Here's what we're going to do. If it's part of a concat node, the thing you're concatenating. Okay, so if this thing exists, if this is non-zero, we follow that and grab its name. Otherwise, we grab this. So in this case, decalref will be 0. In this case, decalref will be 0. In this case, decalref will be a node pointer to this. I think is what we do. That seems reasonable to me. Now we just have to do it. We can say, let's go back to the parser. So this whole thing we're not actually doing. We're going to say, well, first, let's replace all of these. This will be text. I feel like the type can be that too. which makes this way more complicated. Because it could really be any part of it. You can really concat any part of it. Damn it. This is more complicated than I thought it was going to be. Man, okay. Let's just do it. Let's do it for both. Let's do it for both and see where it takes us. Luckily, this will only be on decals. Although, no, it can't. Well, let's see. Hold on. So it can't be on the symbol. Function call. Yeah, I feel like it could be on anything, man. Anything that has a name. Which gets complicated really fast. And I wonder if this type of functionality, instead of complicating all of this parsing stuff, I wonder if this functionality is better left to metaprograms. Because I don't think I've actually hit a scenario where I need this yet. Like, did I need this in... Did I need this in here, for example? Like, no. I actually don't know if I need it yet. Maybe I hold off until I need this. Because this complicates a lot of things. A lot of things. What does my to-do say for these concat nodes? Yeah, I don't really have a good explanation for why I need this right now. The argument would be, if you're using snippets to duplicate a bunch of code, like in a function, you would want to be able to pass down a variable name, or add on to one. But I really do wonder if we should leave that kind of thing to metaprograms. I'm gonna punt on this for now. And say, implementing concat is going to be quite complicated if we want it to apply to anything, to any possible identifier. Currently, identifiers are just strings, and we just get token text pretty much everywhere for them in pretty much every case that wants them. To support concat, we would have to fundamentally, I don't think that's how you spell it. We would have to change the very core of how we parse them to allow for concats in the middle. Then CodeGen would have to link up the declref and replace the node's name with the concatenated string. We'll say, if this were just identifier names, it wouldn't be so bad. But to restrict it to just that is dumb, and to support it everywhere requires a deeper structural change to the parser. Okay. We will certainly revisit this at some point because I do think it's worth it just as a feature. It's just going to require way too much stuff right now. So come back to that. And again, right now I don't even know if I need it. I don't know if I use that functionality anywhere. So, or if I even need to use it anywhere. So let's go back and kind of undo some of these things. We can undo all this stuff. Remove this. And parser. Let's just go back on all this stuff. All the way back. That's good though, because going forward it will inform how I think about identifiers and types and all that stuff. So this isn't totally wasted. I mean, I am undoing a lot of code here, but that's okay. Because the thing is, concatenation is not just applying to identifiers. It's applying to types. It's applying to like all sorts of stuff. So I can just remove that. Let's go to Lexer and remove this. Where are we? Okay. So that's fine. We'll come back to that if I need to. So let's go to some of let's go to some of these other to-dos and say let's put tabs in the chunk files. Because right now when we generate these look like totally valid code, but that's because 4Coder is doing that for us. If we open this up in Emacs, suddenly you realize that these things are actually not indented at all, which is not great. So let's do that. Let's go to CodeGen. What did I have it to do here for? I think it's supposed to be pretty annoying. Append node as string needs to know about this. Depending on the type of node you're outputting, if you're doing it to a chunk file, it needs to insert an indent beforehand. But it also needs to accumulate indentations based on the depth. Okay, yes, let's do that. It's going to be annoying, but if you're not using 4Coder, which most people aren't, and if I'm ever just trying to look at like source control to look at my chunks, it's going to be like impossible. So append node as string. Is there a way to know write lines and synthetic line numbers? I think those are cases where I think right lines is really what we need. If it's not right lines, we want to indent them, I think. So let's do... Do we have like cogen state? We really don't. Our cogen state is kind of just these globals up here, which is not amazing for us, but we make do. In fact, let's global cogen state. So, running depth. Okay, so I guess every time we print out one of these, we'll say let's just do this to start. Append string builder 1 2 3 4. Okay, start there. Nothing should happen. Oh right, I can't look at it in here. Every time we build, let's open that. Okay. So, start there, and we'll say we just need to know when we increase and decrease the depth. So, I guess anytime we hit a brace, right? No, it's anytime we hit a compound statement, first of all. Start there. Here we go. So whenever we hit a compound statement, we do that, and then we increase the depth, and then when we're done, or before we're done, we decrease the depth. Let's start there, and just see where that gets us. That'll do a lot for us already, on its own. Okay, that's weird, I admit. Functions look pretty good, other than why that's not a compound statement. Oh, no, hold on. I can't just globally say this. This does not work. This has to happen. Okay, let's do this. Let's create a macro called indent depth. And we're gonna say here, indent depth. I don't know why I put a underscore after this. So, we don't have any variables here yet. No, wait, we do have struct members, so why didn't that work? Do structs have a compound statement, or they just have like a body? They don't have a compound statement, they have a body. So, here, right here. We say plus plus running depth. And when we're done, say minus minus running depth. Oh, look at that. Already. Breath of fresh air already. So, compound statements, let's do that. Even though we did... Right. Return statements. Return statements. Oh, but... Here we do need a running depth, though. Right. I guess after all of these, we will indent depth. Yes. Yeah. And then oh boy. Function calls. We need to let's do function calls. If statements, right? For an if statement, we're going to but see the if statement we do, but if it's a compound statement inside of it, then we don't. You know what? Let's just do it. It'll look better than it did before. I'll say that much. God, this function is just getting grosser and grosser, and I don't like it, but... you know, here we are. Where are 4 statements? While statements. Do. That's probably fine. There's no for loop in here? There's an if, and none of these are working. God, is there really no better way to do this? I don't think there is. Which sucks. It extra sucks because I bet if I open this in Emacs and just select this whole thing and hit tab, it just does it for you. Yeah, it just does it for you. Maybe I'm okay with that. I'm the only one using this thing right now, so... Damn, yeah. Or maybe I can get, like... I would hate to introduce a third-party tool to this, but I could just get something and run it on it afterwards. Let's do that. I don't want to make this function even worse than it already is. And then here, do it for you. Yeah, that's goofy. Yeah, I don't know. Whatever. We'll come back to that. It's okay. So, snippets taking typed parameters. Right, print like asserts. We can't do that yet. So, for example, in Linux platform, here's an assert. It takes an expression and a message. So it'll print out, hey, assertion failed at this file, this line number, blah, blah, blah. But we want this to behave like a print. We want to be able to say, like, our message, we want to construct it. We want to be able to say, like, failed to understand blank, needed blank, or whatever. And you can pass it, like, you know, stuff. And for that to be print-like, snippets have to understand that, well, in fact, I have it down here, right? Snippets would have to understand named argument or typed arguments. So it would have to know this is a short string that we can pass to format string. And it would have to understand any and like all this other stuff. So let's do that. Let's officially remove this old assert message. Do we use that anywhere right now? Could not resolve snippet source. Yeah, we do. And let's do this. So we want to get this working. Which I don't think will be too hard. This one I think we can actually do. So we're going to take a look over at the parser for snippets. Get the name, parent open. So these are currently pre-proc params. The thing is, we don't want you to have to type them if you don't want to. So let's break on that and see if we can intermix them. So let's turn this into just an expression. Let's compile that. And then parser, snippet, there we go. Where do we get the name? Let's do here. The name should be assert message. Okay, great. So, let's do this. Let's say parser cur lexer tokens parser token cursor. Okay. Parent open. We're going to say +1. It's a pre-proc param called expression, right? And next is one called short string format. So these are all pre-proc params right now. Which means the lexer needs to change for snippets. Right? We're just doing pre-proc params for all of these. But can the lexer distinguish between those things? That's the question. Oops, sorry. Bumped the mic. Okay, what we should do here, let's just parse them like normal function call or function parameters. And if they're ones that don't have a type, we know that it's a pre-proc param. So function Oh. Okay, let's just not do snippets specially. Yeah, let's just not do this part. Yeah. Do we have a peak identifier? No. Okay. Skip that, skip that. Let's just not do this part. Great. Now we're just seeing it as an identifier. Great. This is good. This is good. So now if we step back into here, we get the name as assert message. And now, the next thing, let's do this. Let's copy this a couple times. 1, 2, 3, 4. Okay. So this is great. We get an open paren, an identifier, a comma, 2 identifiers, right? So we are now lexing it like normal. Now we can just parse it properly. We don't have to change the lexer at all, which I didn't want to do, because the lexer is supposed to be kind of dumb and not care about what it's lexing. Right, so we don't want preproc params here. We want... well, what does a function decal look like? It just has params, which is what we want this to have. So let's go look at parse function decal. Do we have params? We sure do. Okay, great. Parse param decals. Let's just do this. So if we see a snippet, we create the child node, expect an identifier, grab it. If it's a parent open, we advance and we can just call. Does this do the closing? No. Boom, boom. Parse param decals. Parser. Snippet node. Not snipper. Snippet node. Then we grab the next thing. No, we don't. This puts us where we need to be. Expect it. Grab it. We expect a curly open. Okay. Couldn't resolve snippet sort. Great. So we're back to, okay. We're back to working like we were before, which means if I put this back, do we still work? No, because these are no longer preproc params, these are normal params, which is fine. In fact, let's get this one back to working order and then move on. So these are now parameters on the tree. If we take a look at the tree, oops, this needs to be tmax. Assert message. Here we go. So these are now parameters. These are not preproc parameters, which means they can be typed. And in fact, we already handle all of the stuff that we need to handle for them, which is really good. But CodeGen currently needs to understand where we do snippet. Here we go. Snippet param index for string. Oh, one thing I want to see. So right now, these are untyped, right? It's a parameter called expression, but it has no type. If I give it a type, perfect. It's now a B32. That's exactly what we want to support this. So here, if child type is a param and string is the param name, this should actually be the decal variable name. Now, is that all we have to do to start to get this working? We didn't compile. Hold on. This is the decal param. What did we generate? Let's look at what we generated real quick. If not expression. Right, we're not expanding this yet. Because snippet param for variable. This is a decal. This is decal variable. Decal variable. Okay. Replace in string exactly. Here we go. Replecki. This is a decal param. Okay, this is a decal variable name. Great. Update snippets. Since snippets are just AST copy paste, we need to update all the decal refs in the copy node with the actual one from the call source. Right. So assertion failed. Okay, somewhere in here it doesn't like something we did. If we give these types, does it suddenly work? No. Getting close though. So snippet. Well, let's just see. See what happens. See where we break. Assertion failed. Where do we assert that? Dynamic string 421. Okay, let's say if end index is greater than or equal to source length. Okay. Dynamic string. Okay. Where did we come from? Replace string exactly. Query index is 0. So in the string, we want from 0 to... Okay, so query length is 0. Why? What is our query? So the child is a decal param whose name has no length. Okay, why? Let's go back to the parser. Parse param decals. Let's look for AST preproc param and just see if we are missing something here. That's printing it, we don't care. That we're not calling. Okay. So why param decals? This should be allocating space for its name. So why are we not? Let's go back up here. Snippet source. Let's look at the source. Children. We got 2 parameters. Does this have a name allocated? No. Oh, it's in the type if it doesn't have... Okay. It's in the type if its name is empty. Which means if it does have a type... Are we still messed up? Why? Snippet sort. Is this even the right snippet? Am I looking at the right thing? Snippet is a preproc. Oh, we're on push type. Hold on. That's why. This is... Push type is in here. Yes. So, okay, that's why. So, we need to... if... Okay. When we parse a snippet parameter, it's not guaranteed to have a type, which means... Let's do that in the parser. Let's just say that if we parse up variable decal, at the very end of this, if we're in a snippet, right? And we don't have a type, or we don't have a name, rather, at this point. Let's just copy our type. Did we not hit that, though? We're in push type. Okay, that didn't work. Oh wait, are we in a snippet body? We're actually not in a snippet body. Our parent is a... Oh no, we should be. We should be in a preproc snippet. We'll just say in snippet. because we don't have to be in the body, right? We are definitely in one because it's our parent. Oh, no, at this point we're not, though. At this point we are not, because at this point we are in a function call. The snippet thing happens later. Update function call if snippet. That happens here. So for each... Yeah. Okay. Hello, Arch Linux user. Hello, Buzztronic. How are you doing? Somewhere in here we want to say, like, we want to go over all of this thing's parameters. Actually, we don't do that here. We say, can I ask a... Yeah, go ahead. Random question related to C. What's up? I will try to answer it. Just let me know. We want... Here is what we want. My stream setup looks nice. Thank you. I tried to keep it very simple. I just need a webcam and that you can see the code. So I think here, if we updated it into a snippet, any parameters that don't have types, copy that string into their name. Actually, don't have types. Copy that string into their name. The name goes in the type slot, so copy it to the name slot. Actually, that's fine. I'm gonna say, so for each node of type in tree, node, and actually we're gonna say function call is node, and then this is gonna be node. We're gonna look for decal params. I want to learn to code someday. You guys are so cool. Thank you. That's very nice of you. I've been programming for a very long time. So, all right. Buzztronic says, when building C programs with makefile, you typically specify header files included by your C file as dependencies so that so that make recompile that C file when the header changes. But in Meson, you don't specify the header. Do you have any idea why and how Meson gets around that? I'm not sure if I know what Meson is. Mason? I'm saying Meson. The Meson build system. Mason. I keep saying Meson. Open source build system meant to be extremely fast and more importantly user friendly as possible. So I'm actually not using any build system here. You can see my quote unquote build system right here. It's literally just a bash file. And actually, let me not do it in 4-coder because you can't. It doesn't have syntax highlighting. I just call out directly to the compiler in my sh file, or on Windows it would be a bat file, and I call it to MSVC. But I actually don't build with headers and stuff like that. I'm actually doing what's called a Unity build, which if you've not heard of it, you can look it up, but I'll explain it here briefly. When I compile, I am including, where's my main here? I am including my entire program directly, and I don't do an incremental build. So normally you have a make file that's like, okay, build this C file into this object, this C file into this object, this one, like you tell it to build all your stuff, and then the linker links them together, right? Each one of those is a separate compilation. The way I'm doing it here, and then it does that so it can do it incrementally, right? It can say, okay, only this object needs updated. So actually it's not slow. So if you see what I'm doing here, if I build right now, so I have a shortcut, Shift F5 will rebuild. What you just saw there, it just built 11,000 lines across 19 different files in one big single compilation unit. It's all just one giant chunk of code. I'm in debug mode, and it rebuilds it from scratch. There's no incremental building at all. It built it in a second, right? So I rebuild my entire program every time from scratch in just a second, because all it has to do is load all the source as a single thing. Yeah, definitely look up Unity builds. There's one. Another good resource is, and I can actually link to it here. I learned a lot of where I currently do my programming in from a series called Handmade Hero, and actually, this very first episode here, you can see him setting up his Windows build. So this is on Windows, but I mean the concept is the same. Ever since I started programming this way, it makes compiling and building and running just so much faster and less of a headache. I hate having to deal with like other build systems and bringing in, like, I don't want to have to learn make and CMake and all this stuff. I just want to build my program. And so that's how I currently do it. But I will also quantify that I am also not using any external libraries. The only things I'm pulling in here are system headers. So if you have a bunch of libraries you're pulling in that also need built and stuff, you probably can't get away with that in quite the same way. It depends on what you're doing. M. Joyful says, hard part is long typing for me. I only have one hand, so it makes typing not so fun. That's really rough. I think, though, there are plenty of tools these days that I think, even at the very least, just how good dictation is, like text to or speech to text. I have a feeling you can actually probably, like, you might be surprised. I don't know if you've ever given it a try before, but I have a feeling there's a lot of options for a lot more people to just get text onto the screen in a way that would work. I would suggest if you are seriously considering it and curious, I would definitely recommend seeing if some of those options exist, because it wouldn't surprise me at this point. And I'm curious if you have specific interests, like just general software, if you're interested in making games, or what your focus would be. Okay, where were we? We were doing snippet calls here. If the node, if its name is empty. Then we just want to copy the type into the name. Okay, we're still failing. That's not great. Let's look at the source again. We are currently looking at push type still. Children, param, info, variable. Okay, so that didn't work. Its name, its length is 0, which I thought we were checking for. And its type isn't, and I thought we were just copying that over, but it looks like we're not. So let's figure out why. We're looking for parameters. If not name.length, then okay, what? Let's just step into that. Let's see why. If we even ever hit it, is the question. Where do we do that? Here we go. No. Where are we? 219. We're way in the wrong spot. Here we go. Okay. Turn that off. Okay, we just don't hit it. So that's not good. Replace snippet calls. So when we did update snippet calls, why did that not... Let's just stop here and look at node. Sorry. Blanked for a second. Okay, snippet call. So, its children. Oh, these aren't params. These are decal refs. What? Oh, this is the call. Oh, this is the call. I am in the wrong spot. This is the call. This is not the... Jesus. These are calls. I am being dumb. It happens. I'm just not paying very close attention. So, snippet. Update snippet, copy decal refs. No, this is gonna be snippet node is a preproc snippet, and then we call parse param decals. Then we call parse variable decal. I thought we just tried this. Thanks for the follows, guys. It's cool. I'm really enjoying doing these streams, and having people actually watch and seemingly care about what I'm doing is cool. So appreciate it. Okay. We are doing... Who writes C in stream anyways? Yeah, I feel like there aren't a lot of people who are doing this kind of programming on stream, which I think is maybe partly why it's a little more gratifying for me, because I do feel like the people who come to see this are getting something that isn't super popular on stream. So hopefully people like it. The eventual goal here is to get out of this whole metaprogramming parser stuff and to actually start building like a cross-platform library for doing all sorts of stuff. But I'm doing all this metaprogramming stuff first to set up some powerful tools. So we'll get there. Okay. Parse variable decal. So I thought I already tried this part, but let's do the very end here. If parent type is an AST preproc snippet, let's just break here. How about that? And let's remove the other one I had here. Did I already? Don't know why that's there. That I'm still doing. This I can get rid of. This I can get rid of. See you, Bustronic. It was nice meeting you. Thanks for the follow. Hope I see you again. Okay. I think that was. I think I already got rid of the last one that was in there. Okay. We don't have parent. We have. Oh, because we return it. Okay. So here, I guess. Here we have a parent. So if we got one. There we go. Let's do that. Let's go back to the parser. We'll say if parent break here. Great. And our parent is assert message. Great. And our variable decal node has a type, length 10. Okay, we should be able to do this right here. So, we'll do the same thing we did before. If variable decal node, if not, if we didn't get a name length, that means it's in our type, and we get it from the type. If this is a snippet param with no type, the name is stored in the type field. So let's copy it over to the name field. Okay. Oh. That's a good sign. We compile again. So that's a really good sign. It means that the... Oh, that means our push type should be working now. We should be back to normal. If I do like a... Great, that's fantastic. Okay, so we now work regardless of if this is also typed now, we shouldn't crash. We should be fine. Great. Okay. So these can be typed optionally, which is awesome. That's the first step of what we wanted to do. Next part is we want to actually handle well, wait a minute. Does that just work? Are we just like actually good? Can I do that? No. So that doesn't work. What about this? Okay, great. It doesn't like that, but I think it's because... No. Okay. So it doesn't know what that is yet, which is fine, because snippets aren't expecting to take optional parameters. And actually... Well, yeah, let's go back to CodeGen now and let's look for snippets. I am going to turn my AC off because I am cold. Where's my... Okay. Update snippet calls. It's the part where we replace stuff. Yes, it's in replace. So, replace snippet calls. Here we go. So, we need to couldn't resolve snippet source. This is where we're failing right now. Couldn't resolve snippet source for call on 94 in platform DB. Here. So we can't resolve the snippet source for that, which is get source node for... Oh, that's a bad... Well, it's not bad, it's just it's confusing, because this is not referring to the source file. This is referring to like the source code or the source node that it's coming from. But that's okay, we can leave that. That's fine. So this is because we can't find the decal node in this case, because the decal ref in this case is assert message. Right. So the type, the connecting of this decal ref did not know that it needed to connect it to this, probably because it doesn't understand these optional parameters. That's my guess. So where do we do that? Connect decal refs. We update snippet call. We connect decal refs at the end, so connect decal refs. Do we do snippets here? Here we go. Update function call if snippet. Here's where we connect it up. Here. So this needs to match this, but this needs to discount optional parameters. So how do we do this? We want to say I came back just to write this message. Okay. What's up? Oh, okay. You found the answer to the question in Ninja Manual. Okay. Mason uses Ninja as a backend. The problem with headers is that the full list of files that a given source file depends on can only be discovered by the compiler. True. Different preprocessor defines an include paths cause different files to be used. Some compilers can omit this information while building, and it should use that. Okay. Okay. Gotcha. Cool. Well, I'm glad you found it. I could not have given you that answer, so I'm glad you found it. And thanks for the follow, and thanks for hanging out. I hope to see you in the future. Assuming you're gonna take off again. Okay, so this doesn't have to match this exactly. It just has to match the minimum. So we can say snippets can have optional params on the end. So check for those. So account for those. Okay, so in this case, we are calling it with 2 parameters, which are the required ones. So to match it to this, we need to know it would also match. So it needs to match if this is okay. All right, let's do this kind of slow way, but just because it's easier for me to think about right now. We'll say start at 0, and then we'll just say for each child node of the node. So for each child of the snippet, if child type is AST_decal param, and it's not an any of. And how do I tell that? I think we have a property for it. Yeah, if it's not an any of, or it's not a, no, if it's not an ellipses. How do I get that? Is it just the name? How do I know if it's ellipse? For each function type, param, if name is ... then... Okay, so it's the name. I just have to grab the name. It's a little weird. Do I have like a function is ellipsed? No, okay. If it does not equal this, we will add to num snippet params. Okay. I think we're working again, but Wait a minute. Hold on a sec. Did I just misread that error, though? Let me just double check this. No, because it couldn't even match it. Never mind. We're good. We're good. So, now we match properly. We're matching properly now. We just don't know what these things are because this needs to be, let's just say format. Let's just see if this works. Okay. Message was not declared. Wait, what? Assert. Right, we're passing a 0 now. So, right, because this has to be a different thing now. So, assert, we'll just pass nothing. Where are we erroring now? In main, assert message. Message was not declared. Why do we have something called message? Because no, I replaced it. We have nothing called message anymore. Let's see what we're generating. Let's look at this. Assert message. Let's see. Assertion failed. Boom, 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 boom. If message. Why is this? Whoa, whoa, whoa. Oh, duh. Okay. I need to pay attention. Format.length. Oh. Right. This is now. Okay. Data format.length. What? Wait, what? Oh, wait, no, wait, hold on. Can we even do this? Hold on. I'm mixing these things up a little bit. Yeah, this is a textual replacement of this. That's not actually a variable. Right. This has to change. This is no longer this. Forget this. Forget this. This needs to be print format ... Okay. Okay. What if I do this? Print test. Print. Wait, short string depends on print, depends on short string? What? Oh, wait a minute. That means I can't call. Okay. I wouldn't be able to call assert message in here if it's print like. This is the one place I can't call assert message. I don't know why I'm calling it here in the first place. That's enough. So now why? Short string should not depend on print at all now. So why does it think it does? Oh, it does because assert is calling assert message. Man. I don't really want to duplicate this, but why don't we do this? Do this. We'll do this whole thing except for no, we'll just say assert. Boom, boom, boom. Defer, exit. Okay. Then here we can call assert expression. I think I can nest snippets. We're gonna see if this just explodes, but I think I can do that. And then we call boom. Okay, we can remove this whole thing. And this is gonna be I don't know what this to do is even about. Truly. So we can just do this, but instead of doing, we don't have to exit, and we don't have to write anything. Actually, can't this just work like this? This is our assert, and thanks to defer, assert message just works. This might just work. Oh, that's awesome. Okay. All right. Okay. Oh, that's fantastic. But we do want, I forgot that we do want to print out the expression. Oh, that's what that okay, that's why. We need to stringify the expression. Right, because we want this to say assertion failed. Well, what were we doing before? Hold on. Oh, we didn't. That's why. Okay, we weren't printing out the expression. Where now we can. So, common. Do we have an assert in here? Assert message. Linux. Assert message. Yes. So we say assertion failed. Where do we put the expression? Arrow expression. So we get to say when we assert, we always put the arrow expression. So always the arrow. And then the expression. We're going to stringify expression. That should work now. And then new line, and then exit. But we can also print out this. Actually, what do... Yeah, how do we want to do this? We always print function arrow expression close paren, and then on a new line, just the message. Yeah, so on a new line, the message. Yeah. Oh, that's when that's on a new line though. Let's do this. We will say assertion failed. This, that. Okay, so on this line, false. And if we have a message, we'll go to a new line. We'll indent, and we'll do the message. With another arrow, I guess. That's what we're doing over there. Boom. And we can say, testing, we can say, oh wait, we're doing, hold on, that didn't actually work. This should already be assert message. We can ignore that. We can assert on message, which should defer. Oh wait, is defer in scope? It is. That's why. Let's remove this scope and do that. There we go. Okay. We're gonna have to do... You know what? Let's just do this. Oh, I want this to be clean. I'm probably over-engineering this, but I really would like this to be as clean as possible. So, we say, if not expression, there's no way for me to defer this exit here. It defers it to the end of this if block, which obviously that's deferred. So or that's already at the end. So maybe we just duplicate these. I'm overcomplicating this. It's fine. Maybe we even have these look a little different if we want. So now, right now, assertion failed. So this should work just fine. We still want to exit. Great. And then so if this is not just testing, but like That's awesome. So now we see the thing that failed as an expression. That's fantastic. That's exactly what we wanted. Oh, that's so good. So can we just pass this on through? Unhandled node type. Okay. We're very close. All we have to do now is pass on this any parameter down through this. And we're done. We have print like asserts. Well, it means you can actually make print like snippets in general. You can pass it down to print. Oh, okay. Very close. Almost there. This doesn't work, does it? No. Well, actually, that no longer even connects. I wanted to be able to do that. So we can say, assert that x is greater than 4,000, but if it's not, our message is got x. That's what we're trying to support right now. And if I do this, we don't even match. So let's fix the match first. This should be greater than or equal to. Okay, we fixed the match. Unhandled node type and get param type. Also question, if we have one that matches exactly, okay, this actually doesn't do anything at all right now. Let's not get ahead of ourselves. We match, so now let's break in get param type and just see what we're seeing. That is in util. Oh, I have to make Visual Studio so hard to navigate in order to stream. It's okay. Get param type. Okay. We are here. Generate function templates. We are generating. What are we generating? Where's function call? Print. We're generating a print function. We're probably generating the print function. Okay, we're calling assert message here, which is just inserting this chunk of code into the tree here. So we're probably generating this print function here, I think is what's happening. And we're unable to determine the type of something. So generate function templates. We are in a function call. Corresponding param index is 2. The param type is short. Okay, we're actually on format right now. We're on format. Function call children 2. Oh, wait a minute. Why are we on 2? Extra. We're on the extra parameters, that's why. And the corresponding param index is, yeah. In order to match to hold on a sec. Where actually are we right now? I'm a little confused. Create parameters that match from the call site. Function is ellipsed. The number of extra parameters are the 2 that we were called with, but we weren't called with, we were called with 2. But we only require 1. Should we have already been expanded by this point? I think we should have already been expanded by this point. I think we should have, because the parameter that we're getting here is the this any unpack. I feel like that should have already been unpacked by the time we get here. Unpack ellipses params. So I'm a little confused because we do that up here. We stop right here if we fail right here if there's an unpack that needs to happen. But we don't unpack it till we're down here. So how are we doing this part? Function call. And what is unpack doing? For any of these, we create a decal ref to... Yeah, that's the part where we do the unpack. So how is it that this part's even working at all? There's something I'm not remembering about this. So what are we looping over here? For each function template, we loop if it's an ellipsed function. For each extra index, we look at what the function call had. Oh, and in this case, the function call doesn't... The function call should not have an unpacked thing. This is for us. This is confusing. But what that means is that this over here when we insert the node over there, we need to unpack right. The snippet call, when it gets inserted, needs to unpack its arguments if they're packed. That won't just magically work. Okay, we need to go back to CodeGen and back to the snippets. And when we do the copy, here. This is a expression. Any unpack? Yes. If it's one of these, let's just assert false and see if this is the case we're hitting. Which it is. Okay. If we hit an unpack here, we have to unpack it right here. In our copy. So print AST. Let's print out the source here. So, right, when we see this, we need to replace this. Hold on. So there's our call. Do we have a call source? We need the call source as well. Okay. Here's the call source. Here's where we called. This here. We need to unpack this. We need to replace this node with a bunch of nodes that are here onward, just like we do with function calls. So in here, it's just a literal string. So what we pass to print is format and that one literal string. Make sense? Probably, hopefully, I don't know. Feel like I'm deep in some crazy stuff right now. So we need to find in our function call, we basically need to do the same thing we're doing over here for templates. Actually, is that what this is telling us? No, this is if the function calls part of a snippet. Which it is, actually. I feel like this... Hold on. This might already be doing this for us if we just let it. I don't think this is going to work yet, but... Okay. Okay. Hold on. Let's just hold on a sec. Are you sure it's defined? Where do we do that at? Defined. Right here. For format, we don't have it for format, which is this. It didn't know how to match it to this. Which platform 30. Let's break there and see what's happening here. Not this, but this. Okay, where are we? Generate function templates. The function call is print, right? We knew that. What is node here? the function template is print, right? We knew that. So, num required params should be 1. Yep. And call arg. What is call arg? It's a decal ref called format. And what is our parent? Where are we right now? Call arg. Parent is a function call whose parent compound, whose parent if, whose parent is compound, whose parent is ifdef, whose parent is compound, whose parent is a snippet. Okay. That's why, because we're inside of we don't want to be doing that here. Right. This is not the right place for this. Part of snippet. Yeah, we still don't want to be doing that. That's fine. So we're at the place where... Okay. That's not where we want to do that. We do want to do this where I said initially, which is here. Ooh. That's not good. Okay. When we unpack, or when we hit an unpack, let's do what we were doing before. Let's just do these two things. All we have to do is literally what I just said before. We need to starting from here, replace this node with this and all subsequent nodes. That's it. So, first thing we can do, for example, is just say remove node child, and that should go away. It didn't. Why didn't it? We're in the copy. Oh, that's the source we're printing. Let's print the copy, shall we? Wait. Snippet copy node. Update snippet copy. Here's where we need to do that. Because we're copying... No, we're copying the source. Alright, now I'm actually confused. The source and the snippet copy should be the same thing. But they're not. The snippet copy is actually the call. Why? See, so we create a copy of the source. Is it because I've already replaced stuff? Hold on. It's quite confusing, but it's okay. We should be getting a copy of this whole thing. Which is why I'm so confused. Like, why aren't we? Ah. Yeah, see, even here, I don't understand. Am I printing other things out and just getting confused? Okay, I am in this case. Okay, not printing anything out. Let's do these two things. There. Okay, that's what I wanted to see. There's our copy. Right? Right. Then we come up here. And we should see the same thing. Oh, this is so confusing. How is this possible? Here's a cert message. And then this copy is just a decal ref of the format. Is this like happening way later or something? Let's do this. Okay, here's a cert mess. Okay, it is. It's happening way later. That's why. Other things are getting called and we're getting confused with that. So here are those two. There's the original. There's the copy. Okay. Wow, what a waste of time. That was that was dumb. Okay. Ignore all this. Let's just go down here. Move this. Boom, boom. Let's do this again. And see that it has in fact removed it. Here's the snippet. There's the original. We scroll down to the copy. Why? Because once we get here, update snippet copy decal refs. Source. Oh, because then we do it on the child again. We go down, 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 down through the child. That's why we're only seeing this. That's confusing. But you can see we did in fact we replaced format with this, and then I think we did remove the child. If we don't remove the child, There. Okay, we are in fact doing it. I was just confused about where we're at. Jesus. Okay. So now we just need to find the corresponding node for this child, which in this case, it is the call source. It is... Oh, come on. Emacs. It is 0... No, it's 0, 1, 2. 0, 0, 1, 2. It's the same thing. Should be the same argument. Okay. We don't need this anymore because we're going to eventually replace it. We're going to say... Well, actually, yeah, that's fine. We can... We're replacing it with multiple things, so that's fine. For... we'll say param index equals... child ID or child index, I forget what I called it. Param index is less than get num valid children. Call source. I think. So let's just try printing call source children param index. Let's just see what that does for now. Okay, we got 1. Oh, but that's the format. Okay, this needs to be +1. Now we don't see anything because there's nothing to copy. But if this took another parameter like test, we should see test. Great, okay. Cool. So, to insert is create node copy of this. Then we insert after child to insert. Then we remove the child. That might be it. That might be the whole thing. Stop asserting. Dude. We're working. Assertion failed. X needs to be greater than 4,000. We got 3153. Boom. We did it. We now have print-like asserts. And to do that, we now have snippets that can take typed parameters and properly unpack any. separate to the way that function templates do, and thus these aren't as robust, or at the very least, they have some limitations. For example, you cannot, for any loop over them, get their types, etc. Okay, great. It got very late, but that's fantastic. We now have asserts that are print-like. That's fine. Cannot resolve snippet source for call assert message, right? Because it doesn't match one. Let's make that a little bit better of an error. Snippet source for call. Check parameters. That's not a great error message, but at least we can give them a hint like, hey, check parameters. That's fine. But if this is just an assert, there we go. Oh, that's so great, dude. Oh, that's awesome. Let's see if we have any other asserts we can replace. New assert. Should this be clamp and be a warning? I don't know what new assert is, because we have a plenty fine assert right here. Yeah, should this be a copy and a warning, though? Or a clamp, rather? Maybe? I don't know. We're going to have to come back to all this stuff way later. This is the actual platform code, so... Which we are not doing yet, like the ultimate library stuff, so... Great. We thought there was a node, but there wasn't. Sure. Okay. Cool. Well, it's late. I'm really glad I got that working. That's awesome. Do we still have the to-do in there? I don't think so. Print to-do. Snippets with type parameters. Great. Nest stringifies. Sure. Sure. Wait, this fails? That's weird. Because this is where I said why we need concat. Yeah, okay. Cool. All right. Well, thanks again for watching, everybody. I'm definitely going to call it a night. I'm glad people are in the chat and talking and stuff. I think it makes streaming a lot more fun. So, thanks for following if you followed. And yeah, I'll probably be streaming tomorrow as well. Last day of the weekend. Gonna start tackling more of these to-dos. we're getting down there. So yeah, thanks again. Have a good night. Have a good day if your day is just starting. Whatever. I will catch you all next time.